Okay, bivariate data is a set of data made up of two paired variables. If there is a relationship between the variables, the data can be described as either linear or non-linear. So as long as there's some kind of relationship, you can either describe it as linear, meaning the data follows a straight line, or you can describe the relationship between the variables as nonlinear, meaning it follows some kind of curve or bend or just some other relationship that isn't a perfectly straight line. So anytime you have a set of random points on a grid, you're thinking, is it linear or is it nonlinear? That's the first question you're going to be asking yourself. Once you know if it's linear or nonlinear, specifically, once you know that it is linear, you're going to ask yourself a second question. So if you know it is linear, the second thing you're going to think about is if the data shows a positive association or a negative association. So once we have a linear set of data, either the line of the points either the line that follows the points will be headed up on the graph, kind of like a positive slope does, or the line will be headed down, like a negative slope does. So a positive association specifically means that both sets of data either increase together, meaning that as the time in this case goes up, the number of jumping jacks somebody's able to do will also go up, or they will decrease together. So if you have less time, you can probably do less jumping jacks, and if you have more time, you can probably do more jumping jacks. So the relationship is positive because the two variables increase or decrease together. The opposite is a negative association, meaning that as one data set increases, the other variable will decrease. So an example of this would be the number of flu shots given compared to the number of people with the flu. As the number of flu shots given goes up, the number of people who actually contract the flu goes down. And that makes sense. The more people who are vaccinated, the less likely that population is to get the flu. So this is a negative association because one variable, flu shots, can go up, while the other variable we're comparing it to, the number of people with the flu, goes down. So to kind of encapsulate, the first question is, does the relationship have a relationship, or does the data have a relationship, and is it linear or nonlinear? And if it's linear, the second question you need to ask yourself is that relationship a positive or a negative linear relationship? The third type is, we talked about linear and nonlinear, but sometimes the data appears to have no relationship at all. So if you have something that looks kind of like a shotgun blast of random points, and you can't really draw a line or a curve to match these points, it's just sort of random, we say that the data has no relationship. This means that changes in one data set do not affect the other data set. So an example of that might be if you're comparing people's shoe sizes to their test scores. As the shoe size of a person goes up, does their test score change? Unlikely. The shoe size somebody has nothing to do with their test score. You can have somebody with really big feet get a good grade, and somebody with really small feet get a good grade. And the shoe size has nothing to do with it. Another example is age and internet usage. Maybe this would have been more true in the past. It would have had a relationship, but nowadays pretty much everybody uses the internet. And as our age increases, we still use the internet probably about the same amount. Older people use it for work, younger people use it for fun, and everyone in between uses it for work and fun. So there's really no relationship. Some people might happen to use it less, but your age doesn't really determine whether or not you use the internet a lot. So let's look at a couple examples. the first scatter plot, I see a bunch of random points on the graph, and it does appear to have some sort of pattern to it. If you see a pattern in the data, that probably means it has some relationship. And the first question is it linear or nonlinear? And looking at that, that's a curve, so I'm going to call that nonlinear. B might be a little, and notice, once I find it's nonlinear, there's nothing else to do. We're not going to talk about positive or negative because at some point it goes up and at some point it goes down. So you can't really describe that as positive or negative. It's just nonlinear. The second one, this one, it maybe isn't a perfect, but it does seem to kind of follow a pretty straight line. So I will call that relationship linear. And now the second question you need to ask yourself, is that positive or negative linear? And looking at that, the line is headed down. As one variable increases, the other decreases. So I'm going to call that negative. And now let's look at the last one. Take a moment and think to yourself. First question, is that linear, nonlinear, or no relationship at all? It is linear. These seem to follow some sort of line pattern, so I'm going to draw a line through it. We'll talk about trend lines and predictions in the future, but for now we're just trying to see is it linear, nonlinear, or no relationship. Once I've found that it's linear, my second question becomes, are the variables increasing together, or is one decreasing as the other increases? Basically, is it going up or is it going down? It's going up, so as the temperature increases, the sales increase, so that's positive. The last one, or not the last one, the last row. This one, again, take a moment and think. But it is linear. As the hours studied increase, the grades also increase. So that makes it positive. Once you figure out that it's linear, think to yourself, is it positive or negative? Looking at E, is that linear, nonlinear, or no relationship? It is nonlinear. You can see there's a curve there, so it is nonlinear. And then the last one, F. Is that linear, nonlinear, or no relationship? You can see it's a random scatter of points. There's no pattern, so we say there is no relationship. Another way you might hear this described, no association. Okay, let's flip over to the other side. So, sometimes they're just going to give you a bunch of points, and they're not going to be on a graph for you. So what you're going to have to do is instead open up a tab of Desmos, and you're going to have to put all these points in a table. So let's look at example A. So the first thing you need to do when you go to put these points into Desmos is to click plus, the plus button, and you're going to add a table. So I'm going to click plus. Let's make this a little smaller. And I'm going to add a table. Then add all the points to the table. So I'm going to put in 1, 0, 1, 4, 2, 5, 2, 6. Do it at your own pace, but I'm just going to add all these points to the table. And then what you want to do is you want to try to get a good look at the table. Sometimes it helps to pinch and spread the points out to get a better view of the data set. But if you look at this, it might look kind of linear, but as I expand it out, you can really start to see that there is an eventual curve to this data, and it's not actually as linear as it might seem. So you can see that it starts out increasing kind of slowly, and then as our x values increase, it's increasing faster and faster, which is giving it a bit of a curve. So we're going to call that nonlinear. Go ahead and try to put all these other points into multiple tables and see if you can determine the linear or nonlinear relationship, and if it's linear, if it's positive or negative, and then come back to this video and compare your answer. Okay, here's example B. You can see that there's no association with this data. It's just kind of randomly scattered. See, you can see that that looks like it's a pretty good line. So that's linear. And that line appears to be going up. As x increases, so does y. So that's positive. Kind of hard to tell exactly. It might look nonlinear. I could see an argument for linear. It's not really starting to decrease too much faster over time. So I'm going to go ahead and call that linear. It does appear a bit nonlinear. It does have a slight curve to it, but usually if it's nonlinear, it's going to be a lot more obvious than that. So I'm going to call it linear and negative because those points are decreasing over time. Example E, again, it's a pretty okay line. It's not perfectly straight, but it doesn't have to be perfectly straight. It's just about getting a good idea of the trend. So again, that's appearing to be linear. This time, though, the line is headed up, so it is linear and positive. Last example. And then this last one, example F, does appear to be a pretty good line. This time, though, it is negative.